good evening to one and all of you. So I hope I'm audible and visual. If not, anyone of you can confirm me. Okay, so let's wait for 5 to 10 minutes so that everyone can able to join this session.
Hello, madam.
Yes, hello.
Madam, assignment 5, the question number, what is the, I think the solution is wrong. Uh, the question number 8.
Question number 8.
Yes, madam. I
Uh,
think this is 14 by 5, I think.
okay, actually, to related to my questions and
And madam,
question number
9, question number 9, it is also. Can we solve this, madam?
which question related to which one is posted on the assign that
So, madam, this question to find the energy of the sequence. This question 9, for question number 9 and question number 8.
which I have done or on that is in on NPTL that assignment has been uploaded there.
Madam, solution given there, but but because there have mistake in question number 8, this is when the find this question, solution there, the summation of the all the terms is given as 12, but it is 14. Okay, madam, the solution also there, but it is wrong.
I'm asking which
5,
has
yes, madam. Yes, and 5. Question number 8 and 9.
8 and 9. Okay, which has been uploaded there in NPTEL website.
Yes, madam.
Okay, whether they have released that assignment solution or not, you are
So,
asking.
it is release the solution.
They have released a solution. Okay, then in that case, I need to check. Actually, I'm not currently accessing the current assignment which have been updated there. Okay, I will see that.
Okay, madam.
There is a problem on assignment in question number 7 and 10. Someone has asked in the last week, so I don't know whether 8 and 9 you are asking.
Yes, madam.
Yes, it would be a 14 by 5. I didn't solve, but just I have counted it from here, so it is
Hi,
14.
yes, madam. This is 14 by 5 and the 9, question number 9, it will be, it is, I think it is 9, question number 9. It is 14. The energy of
Question
the
number,
sequence.
yeah.
Yes, madam. Question number 8, it is 14 by 5. And question number 9, it is 14.
Duration.
The sequence have given the
Okay,
zero,
okay.
1, 2, and 3. So every square value, summation of the square value equal to 14. When I consider as we find the energy.
Yes. Okay, so they have given advancements. Okay, I will ask them. And you can also post it in the discussion forum also. Okay, this Anis is there. Have they have replied in the previous doubts or not? You are asking about question number 7 and 10 also. There is some. Hello.
Madam, question number 7, the answer is a minus 1 by 3, but it is 0 as considered as a integer value. So it is a equal to 0. Not a perfect value. Question number 7. When you can calculation, we get the minus 1 by 3. The question number 7. And madam, and question number
But in
10.
the last week, someone has asked about question number 7 and 10 has
Yes, madam. 10
faced
have also
some
problem
problem.
there.
Yeah. So I have also intimated them. Okay, there is some problem, please. So I don't know whether they have replied on the discussion forum or not. And
Yes, madam.
okay, I will check it. I didn't get time to check from their
Yes, madam.
side.
The question number 10, the value of x0, the sequence of x0 equal to, when I calculate, this is a 18 by 4, and x1, it is a 0, but it is not match in the sequence in the option. So I just write and I just answer it.
Okay, okay. If there is any problem in the options or question or answer, they will giving you the grace marks also.
Okay, madam. But madam, it is my problem is that I give 0 from question number 8 and 9, which is wrong answer there. So I get 0 marks from there.
Oh, okay. But whatever you question. If there is any mistake from their side, then they will correct it, and they
Okay,
will
madam.
give that grace marks also.
Okay, madam. Thank you. Okay, madam.
Yes, Anis, you want to ask something? Okay, so hello everyone, a very good evening to one and all of you. So let's start the session. I hope I'm audible and visible. So any one of you can confirm me. Okay, so yeah, hello everyone. My name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur, and the instructor for this course is Professor Syamal Kumar Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 6 live and interactive session on signal processing techniques and its applications. So I hope all of you have gone this week video lectures. So first we will go through some theoretical concepts, then we will solve some assignment, some problems which will be very similar to your assignment questions. Okay, so you can use chat box for asking and interacting. And today I will also suggest to please carry one calculator to solve the numerical questions. Okay, so this is a course content related to this week. This is a first one is two dimension discrete Fourier transform, discrete cosine transforms, frequency analysis of a long signals using DFT, short time Fourier transform, and STFT synthesis. Okay, so what is a two-dimensional discrete Fourier transform? So two-dimensional discrete Fourier transform is an extension of a discrete Fourier transform which is used to analyze the 2D signals or 2D data such as an image. Image is a two-dimensional signal as we know that. So to analyze the image we will use the two-dimensional discrete Fourier transform. So it basically converts the special domain signals like pixel value into the its frequency domain representation to by enabling easier manipulation of the frequency component such as a filtering or compression. So for 2D signal, this is the 2 DFT signal equation where f u comma v is a frequency domain representation of a 2D signal. The equation is like this: summation x varies 0 to m minus 1 and y varies 0 to n minus 1 f of x comma y e to the power minus a 2 pi ux divided by m plus uv vy divided by n, capital N, where f of x comma y is the original signal value, that means pixel intensity in an image at the position x comma y, and f u comma v, capital F u comma v is the Fourier transform of the f of x comma y at frequency component u comma v, and m and n are the dimension of an image. Okay, and j is an imaginary unit, already we know that, and that sum will vary from 0 to m minus 1 or n minus 1, where m and n are the dimensions of the image. Okay, so this is the simple image. It is represented in this form, and this one is a grayscale image of that image, and this is a pixel value representation of that image. So for example, if we want to find out the value or frequency domain representation of that point ix comma y, so it can we will calculate like this. Some it will be given, for example here, so it will give in some matrix form. So as already we know that, so image is represented in the matrix form. Some values will be there. It can be 2, it is a 2D, so it can be 2 cross 2, it can be any dimension. Okay, so here I here 3 values representing the RGB image. Okay, so red, green and blue at that position. Okay, so what is the basic transformation of the image? So first we will give it the special domain that is x comma y here input to the some transformation function, then it will give some the function tu comma b, then on that value we will perform some operations, then we will get this operated value r, that is r t u comma b, then again we will apply the inverse transformation to get the special domain representation. Okay, so how we will perform the inverse transformation? So inverse transformation formula is this: f x comma y, that is f the original value, equal to 1 divided by m into n. M and n is the, already we know that the maximum value, right, the dimensions, and where again u varies from m minus 1 and v varies n minus 1, the frequency domain representation at that point f capital F u comma v e to the power j 2 pi u x divided by f plus vy divided by n. Now next point is DCT, that is discrete cosine transform. So discrete cosine transform is also used for image and signal processing, and but particularly it will use for image compression techniques like JPEG. Okay, so it transform a signal or image from a special domain to a frequency domain, similar to Fourier transform, but it will use only cosine function. That means it will use only the real values, not a imaginary values. So already we know that any signal contains two values, x I plus y j, sorry, x plus yj, so real and imaginary. So in discrete cosine transform we will use only real values, we will discard the imaginary part. So that's why it is real and it has a better energy compaction. So real values always have a better real energy compaction, so that's why we will use here only the real values. And there are four versions of a DCT, that is DCT1, DCT2, DCT3 and DCT4, but most popularly used DCT2. So this is a formula for a 1D DCT, for 1D signals. So these are the formula for the 1D DCT. So already you have gone through the video lecture, so I am not describing it here, but you have already, we will solve some problems based on that, then you will able to understand. Now there are also 2D DCT which will be used for image analysis or image compression techniques. So this is the corresponding formula for the 2D DCT. Here I have written this because we will use in the questions, so we will able to recognize or we will able to learn from there if we forward here. So for that purpose I have taken it here, 1D DCT and 2D DCT formulas. Okay, so frequency analysis of a long signals using DFT. So for a long signal analysis using a DFT, we will take there is a one long signal. So what we are doing here, we will just taking some samples of that signals, and then we will multiply some window function, so in order to analyze that particular part of the signal. Okay, so for that purpose here we will do the frequency analysis of the long signals using DFT or using windowing function. So just we are taking the L samples and multiplying with the window function to analyze that part of the signal. Then again we will take some another part and then multiply the window function, then analyze. So this is it. For there is a one long signal x of n, then we will multiply, we are taking some L samples of a window length, where L is the window length of signal Wn. So just we are multiplying where we have taken one small window w of n is equal to 1 for a duration 0 to L minus 1, and there is a one signal. For example, let's they have taken x of n is equal to cos omega naught n. So overall the analyzed function or signal will be this one 1 by 2, that capital W omega minus omega naught plus W capital W omega plus omega naught. Okay, and this is a window function or a rectangular. There already you have studied about the four types of window function. There is rectangular function, Hamming, Hanning, and Blackman window function. So here they have taken the rectangular window function just in order to see how we can analyze. So another one is if there is this type of signal, there are two frequency components. So the window and then multiplied by the window function, then the signal will act like this. Omega at each frequency component there will be the addition and subtraction. So this side and this side, this is minus omega 1, minus omega 2, omega 1 and omega 2. So just multiply that window function, then the frequency component we will get. So if that is omega 1 minus omega 2 less than equal to 2 pi by L, then the two window function, that is W omega minus omega 1 and W omega minus omega 2 are overlap, and as a consequence there are two spectral lines x of n will not be distinguished. So to separate these two loops, the function must be follow this condition, that is omega 1 minus omega 2 must be greater than equal to 2 pi by L. Okay, because so these are the some key concepts related to this week. Now we are moving to the next questions, so that may be helpful to solving your assignment problems. So first question is, which domain does an image primarily belongs to? Option A is spatial domain, option B is time domain, option C is frequency domain, or option D is none of these. So would you like to try this question? Please answer in the chat box at least. So this one is a basic very basic question, I hope all of you have gone through. So which domain does an image primarily belongs to? Okay, so first we will see what is in an image. So an image is essentially a two-dimensional signal, already we know that, where each pixel represents the intensity at a specific location. Okay, already we have seen that example. So that is x and y. So each pixel, that means each point represents a pixel, so represents that intensity at that specific point. So at this point, this represents the intensity of that pixel. Okay, so now we will see what is the spatial domain and time domain. So spatial domain is used for enhancing the image by manipulating the individual pixel based on their spatial coordinates at the specific resolution. So this is a spatial domain. Now time domain is used to analyze the input signal depending on the waveforms observed over a period of time. Okay, so this is a waveform that will observe over a period of time. For example, at this time, at this complete a one cycle. So at one cycle we will use to analyze. Okay, so it is a time domain, and this is a spatial domain. So at that point we will analyze the intensity of that pixel. So image is a spatial domain signal. So image belongs to a spatial domain, not a time domain. Time domain belongs to a signal, and frequency domain is a opposite of the time domain. Okay, so image belongs to a pixel's intensity and this value. So this is a spatial domain representation of an image. Okay, so correct option is A. moving to the next question. So next question is, if f of kl is DFT of f of mn as shown in the equation below, in this equation, then what will be the value of f of k plus m comma l plus n in terms of f of k l? Okay, which option will be the correct one? Can you answer? Okay, so they are saying this is a DFT, f of kl is the DFT of a f of mn, which is represented by this equation. Then what will be the DFT of f of k plus m comma l plus n in terms of f of kl? In this term, what will be the value of this signal? So already we know that frequency domain representation of a 2D signal is represented by this equation. So now if we just shift the signal both direction by m place and l by n place, then what will be the value? So 1 by mn, just putting these values in this equation. M by summation m belongs to 0 to m minus 1, n belongs 0 to n minus 1, f of mn e to the power minus j 2 pi, here k plus m, because it is a k, so in place of k we have put in k plus m, so k plus m by m into n small m, this one, plus l by l plus n capital N. Okay, this one is a l plus capital N divided by capital N small n. Okay, so now we will expand this. 1 by mn summation m belongs to 0 to n minus 1, sorry m minus 1, and this n varies from 0 to n minus 1, f of m comma n e to the power minus j 2 pi, so just I am breaking this one, so k by m into small m plus l by capital N into small n, and also this part is e to the power minus j 2 pi m by m into m, remaining part I am writing here, capital N by n into small n. So this will be the cancelled out, right? So e to the power, I am just writing this part here, e to the power minus j 2 pi m plus n only left. Okay, so we e to the power, so it will vary from 0 to m minus 1, so it depends 0, so it that can be a 1, this value will be 1. Okay, so this 1 by mn, m varies 0 to m minus 1 and n varies 0 to n minus 1, f of m comma n, so I have to remove it from here. E to the power minus j 2 pi k by m small m plus l by capital N n. So which is equal to, already we know that it is equal to this value and this value will be same, so it will be equal to f of k comma l. So f of k plus m comma l plus n will be equal to f of kl. Okay, so option B is the correct answer for this question. Okay, okay, so I hope you have understand this. So moving to the next question. next question is, why is the discrete cosine transform preferred over a discrete Fourier transform in image compression? Why DCT preferred over a DFT in an image compression? So option A is DCT has a lower computational complexity than DFT. Option B is DCT produces only real valued coefficient while DFT produces complex coefficients. Option C is DCT provides better energy compaction compared to DFT. Or option D is all of the above. Which option will be the correct one? Okay, so would you like to answer this question? Why DCT preferred over DFT? So already we know that DCT correspond to discrete cosine transform. That means it is taking only the real values, while DFT taking both real and imaginary. So DCT in the computational complexity case, so DCT has a less number of complexity than DFT because it is taking only one part and it is taking both real and imaginary part. And already we know that DCT produces only real valued coefficients and DFT is complex coefficient, so this one is also correct. And now DCT provides better energy compaction compared to DFT. Already we have seen in the previous slide only it is taking the one value, so it has a better energy compaction than DFT. So in that case D, all of the above option is correct because three of them options are correct. So option D is the correct answer. There is a detailed written solution I have given here. So first, lower computational complexity. So already I have told previously DCT operates on their real numbers, where DFT involves complex numbers, that is real and imaginary part as well. So in that case DCT computationally simpler than and more efficient for image compression than DFT. Okay, now next one is the real valued coefficients. So DCT performs an image into a frequency component using only real values, not like DFT. DFT produces both real and imaginary parts. So real coefficients are easier to calculate, store and manipulate for practical applications. Okay, and DCT has a better energy compaction. It is more effective at concentrating most of the signal's energy into a low frequency coefficient. Okay, so this is the main reason which DCT used for JPEG compression techniques to reduce the number of bits needed to store in an image. So in that case, since all the statements are correct, so that's why the option D is the correct, all of the above. Okay, so I hope you are getting. So moving to the next question. Now next question is, suppose an image is represented as follows by this one. So it is converted to DCT using equation 2. This is one is the equation 2. What is the value of C00? So what will be the value of C00? Equation is given, C u comma v equal to alpha u alpha v summation x varies 0 to n minus 1. That must be m. Or either they have taken n cross n, that is same, 3 cross 3. Okay, that is fine. Y is equal to 0 to n minus 1 f x comma y cos in brackets pi 2x plus 1 u divided by 2n into cos pi 2y plus 1 v divided by 2n, where u and v varies 0 to n minus 1, and alpha n, when for n is equal to 0 value is 1 by root n, when n is not equal to 0 value is root 2 by n. So what will be the, they are asking what will be the value of C00. So how we will solve this question? Any one of you? So it will be the generalized equation is given, so you can put it like I here. Okay, so it is easy to calculate. So here the image signal, that is two-dimensional singular is given, that is this matrix form. So there is 3 rows and 3 columns. That means it is a 3 cross 3 matrix. Okay, the dimension of a matrix already we know that 3 cross 3. Okay. So just a minute. So how we can solve this question? So equation is given just by putting we need a C00 value. So C0, 0. So in place of u and v, we will put 0, 0. Okay. So alpha 0, alpha v is also 0. The value of v is 0. Now x varies 0 to, that is n minus 1. So n is 3. The dimension of matrix is n is equal to 3 because it is a 3 cross 3 matrix. So 3 minus 1 will be 2. Similarly for y is equal to y0 to n minus 1 is 2, right? Now I x comma y cos pi 2x, here x will vary, so that equation also vary, into 0 pi 2 into 3 because n is equal to 3. Now second is cos pi 2y plus 1 divided by 2 into 3, but v is also 0, so it will be multiplied by 0. So what we will get finally, alpha 0, x varies from 0 to 2, y varies 0 to 2, I x comma y, it will be the cos 0 only, and this one is also cos 0, and cos, already we know that value of cos 0 is equal to 1, right? So that will be the 1 only. So finally we will get alpha 0, x belongs to 0 to 2 and y varies from 0 to 2, I x comma y, right? Now what will be the value of alpha 0? From where we will get here? So alpha n here is given, but for n is equal to 0, the value is root 1 by n. So already we need for n is equal to 0 only. So alpha 0 will be 1 by root n, right? So what we will get? 1 by root 3. Okay, alpha 0. So alpha 0 we have got. So I am removing it from here so that I can solve it here. So already I hope you have noted down. So just I am removing it from here. Okay, so we have got the alpha values, alpha 0 values, and cos 0, and the whole equation, that is this one. So just putting C0, 0, alpha 0 is 1 by root 3, already we have seen, and again 1 by root 3 for next alpha 0, and here x varies from 0 to 2. First we will open this summation, I x comma y, y varies 0 to 2. So what will be the value? I x comma 0 plus I x comma 1, because y varies 0 to 2, 0, 1, 2, okay, and plus I x comma 2, okay. So by opening the first this summation we have got this value. Now if we open the next summation also, so 1 by root 3 will be 1 by root 3 only. So now x also varies from 0 to 2. First we are putting 0, then 1, then 2, okay. We are first putting 0 in whole this equation, okay. So I 0 comma 0, first here putting 0, then 1, then 2, plus I 0 comma 1 plus I 1 comma 2. Now again we have to put 1 in all these three, so plus I 1 comma 0 plus I 1 comma 1 plus I 1 comma 2. We have put it 0 and 1. Now we have to put 2 also. So I 2 comma 0 plus I 2 comma 1 plus I 2 comma 2. Okay, so whole equation we have got like this. Now what is the I00, I01, I12 and I10, 11, 12? Sorry, this is a 0, 02 here will be. Okay, 1 2. So this is a 2 cross 2. So if I00 value is this one, that is in first row, and this was in the first column. So 0 0 is this 2, 0 1 is 1, 0 2 is this 2 value. So just putting all the matrix value here, so you will get 1 by 3. I00 value is 2, I01 is 1, then I02 is 2. Just putting these values, I20, sorry, 10 will be 1 again, I11 is 2 and I12 is 1 plus I20 is 2 plus I21 is 1, I22 is 2, right? I am removing it from here so that I can calculate. Okay, so now add all these values. What you will get? You will get 2 1 5 6 6 to 8 8 9 9 5 14. Okay, so 14 by 3, the whole value you will get 14 by 3. That means C00 value is 14 by 3. Okay, okay, so option A is the correct answer for this question. So have you understand this question? So I hope you have understand this question or getting these questions. So moving to the next question. Now next question is, a signal x of n is equal to 3 cos 0.4 pi n plus 8 cos 0.8 pi n is analyzed in frequency domain using rectangular window of length L. What should be window length L for signal to be resolvable if sampling frequency is 60 kilohertz? Okay, so here the signal is given. Okay, a signal x of n is given here. So the signal is analyzed in the frequency domain using a rectangular window of length L. Sampling frequency fs is given fs is 16 kilohertz and the two frequency components of the signal is components of signal x of n is omega n is equal to 0.4 pi, right, this one, and omega 2 is 0.8 pi, right, this one. These are the two frequency components of an x of n. This is in radian per second, already we know that. So as we know that the normalized frequency omega is related to the actual frequency in f in hertz. So f is how it is related, that is f is equal to omega divided by 2 pi into fs, that is sampling frequency. So from here we will get f1 and f2. Okay, so how we will get f1? So f1 omega 1 is given, omega 1 divided by 2 pi into fs, that is omega 1 is given 0.4 pi divided by 2 pi. Fs is given as a 16 kilohertz, that is 16 10 to the power 3. So here we will get, so pi will be cancelled, 0.2. Now further if you multiply, you will get 3.2 kilohertz, right? You will get 3.2 kilohertz. Similarly, we need to find out f2 also. So f2 is omega 2 divided by 2 pi into fs. So omega 2 is already we have written 0.8 pi divided by 2 pi into 16 kilohertz, right? Now here pi will be cancelled out, 0.4 here we will get, so 0.4 into 16 you will get 6.4 kilohertz, right? Now how we will calculate the frequency resolution? Just a minute. Okay, so frequency resolution, just a minute, then we stop working. So frequency resolution, so I have to remove some places so that I can write. So I hope all of you have noted down this, so I am removing it from here also so that we can write the other things. So frequency resolution, sorry I am writing very badly because my pen is stopped working, is represented by del f, which is equal to f2 minus f1, f2 minus f1. Okay, so f2 f1 we have calculated, so from there we can calculate the frequency resolution. f2 is 6.4 kilohertz, right? And f1 is 3.2 kilohertz. So finally we will get 3.2 kilohertz, right? 3.2 kilohertz. So frequency resolution we have got. Now the relation between the frequency resolution, sampling frequency and window length will be so frequency resolution we have calculated. Now I am removing it from here. So just I am telling because pen is not working. Okay. Okay, so the relation between the resolution, sampling frequency and window length is equal to del f is equal to fs divided by L. So we have find out the frequency resolution del f, that is 3.2 kilohertz. Sampling frequency already we know that is 16 kilohertz, and from here we can find the window length. Okay, so frequency resolution is 3.2 kilohertz equal to, this one is a 60 kilohertz divided by L. So kilohertz and this one will be cancelled out, and this one is 60 and it is 0.2, right? So from here we will get L is equal to 1 divided by 0.2, which is equal to 15 if you further calculate it. Okay, so window length, what we have got the window length, that is 5. Okay, so window length what we have got, that is 5. So which option B is the correct answer for this question? So this one is a final answer. Okay, okay, so I hope you have got this. So moving to the next question. Now next question is, reduction of the side lobes of a window is obtained by, option A is decreasing the width of the main lobe of the window, option B decreasing the amplitude of the main lobe of the window, option C increasing the width of the main lobe of the window, or option D is none of the above. So which option will be the correct one? Reduction of the side lobes of a window is obtained by, if we reduce the side lobe of the window, then which of the following characteristics will be followed? Decreasing the width of the main lobe of the window, or decreasing the amplitude of the main lobe of the window, or increasing the width of the main lobe of the window. In which case we can reduce the side lobes of a window. So here we will see the detailed answer for this question. So in digital signal processing, window functions are used in for spectral analysis, right, to reduce the spectral leakage. So what is the main lobe? That main lobe represents the primary frequency response of the window, and side lobes represent the unwanted frequency components which causes the spectral leakage. So here our aim is to reduce the side lobes. So how we can reduce? So there is a trade-off between the main lobe and the side lobes. So narrow main lobes. So if there is a narrow main lobes, then it will be the higher resolution but stronger. There will be the also a side lobes will be stronger, side lobes will be there. Okay, if main lobe is wider, then there must be chances the lower side lobe. That means lower resolution but reduced side lobe. So wider main lobes separate the energy which reduces the side lobes level. So if it is a wider, so that will reduce the energy in the side lobes. So this is why the window function like Hamming, Henning and Blackman had a wider main lobes but lower side lobes as compared to rectangular window. So increasing the width of the main lobe, that will reduce the side lobe. If we increase the main lobe width, then it will reduce the side lobe. Okay, so that means increasing the width of the main lobe of the window to reduce the side lobes of the window. Okay, so option C is the correct answer for this question. To reduce the side lobes of the window, we have to increase the width of the main lobes of the window. Okay, So moving to the next question. So next question is, a speech signal x of n is frequency analyzed using rectangular window with 1024 point DFT. If sampling frequency is 16 kHz, then what is the maximum frequency resolution of the signal? So a speech signal is given which has been analyzed using the rectangular window with 1024 point DFT. That means that is n is equal to 1024. Okay, and sampling frequency is given as a 16 kilohertz given. Okay, so already we know that frequency resolution is defined by frequency resolution, that is del f, is defined by fs divided by n point DFT. Okay, so fs is given, n point DFT is given, that we can directly calculate it, the maximum frequency resolution. So fs is 16 kilohertz, that is, and n is 1024. Now if you just divide it, you will get 15.625. okay, 15.625. That is option A is the correct answer for this question. Okay, so this is the relation between the frequency resolution and the sampling frequency and endpoint DFT. Okay, from here directly you can calculate it. Okay, so now moving to the next question. Now next question is, which of the following statements about STFT is true? STFT, option A is, STFT assumes that the signal is stationary within each window. Option B, STFT does not require windowing. Option C is, STFT provides perfect frequency resolution at all times. Or option D, STFT is only applicable to periodic signals. Okay, so which option is correct regarding the STFT? STFT is, already we know that it stands for short time Fourier transform. So STFT analyzes small segments of the signal, assuming that signal remains stationary within that window. Okay, so the assumption allows frequency components to be accurately estimated. So STFT, option A is the correct answer. STFT assumes the signal is stationary within each window. Okay, so STFT stands for short time Fourier transform. Already we know that short time Fourier transform. Okay, so what we are doing here, just taking some part of the signal and multiplied with the window function. Okay, so in that duration it assumes that the signal is stationary within in this window, then we will multiply with the window function. Okay, so option B is not correct. STFT does not require windowing, it requires the windowing. STFT provides perfect frequency resolution at all the time. No, it is not correct. And STFT is only applicable to periodic signal. No, STFT is applicable to the aperiodic signals as well, because short time in that situation we don't know which signal is belongs to, whether it is periodic or not, because it is a random signal. Okay, okay, so I hope you have understand. So moving to the next question. So next question is, which of the following is filter bank summation FVS constraints? Option A is window length, that is NW is less than equal to capital N. Option B is window length NW greater than capital N. Or option C, decimation factor capital L must be greater than N of W, that is window function. Okay, so which option is the correct for this question? Can you answer? Which of the following is a filter bank summation constraint? Okay, so let's see. So the filter bank summation method is used for a short time Fourier transform, and it's for its analysis to ensure perfect reconstruction of a signal when using overlapping windows and destination. Okay, in FES the following terms are defined, that is window length, that is NW. Okay, there is the length of the window function is applied to each frame, and FFT length, that is N, the number of points which will be used for computation, and another one is a decimation factor, that is L, the step size or hoop size used for in overlapping windows. Okay, so the FBS constraints ensures that the sum of shifted window functions in the time domain is constant, and that will prevent distortion when reconstructing the original signal. So for perfect reconstruction of the of that function, the window length must be at least equal to or greater than the length of the DFT or FFT signal. Okay, so that will ensure that each window frame constrains enough sample to capture the full spectral information. That must be NW, that is length of the window function must be greater than equal to the length of the DFT. Okay, so in that case option B is the correct answer for this question. Okay, okay, so I hope you are getting. So moving to the next question. So now next question is, in real time speech analysis, why is a 25 millisecond window commonly used in STFT? Okay, so option A, it provides a good trade-off between time and frequency resolution. Option B, it minimizes computation time. Option D, option C is it ensures perfect speech reconstruction. Option D, it is the shortest possible window for speech processing. The question is, in real time speech analysis, why is 25 millisecond window commonly used in STFT? So which option can be a correct answer? Any one of you can just guess or answer in the chat box. Can you answer? Okay, so let's see. For analysis of a speech signal, as we know that it requires both time and frequency resolution. So a 25 millisecond window captures phenomenon well while maintaining a reasonable frequency resolution. So that's why we will use the 25 millisecond window. So already we know that STFT follows the time and frequency trade-off principle, that is this one. So time and frequency trade-off. So our shorter window improves time resolution, but it reduces the frequency resolution, while a longer window improves the frequency but it reduces the time resolution. So it provides a good trade-off between the time and frequency resolution. So option A is the correct answer. For real-time speech analysis, 25 millisecond window commonly used in STFT because it provides good trade-off between the time and frequency resolution. Okay, it is why that's why it is commonly used for real-time speech analysis. Okay. Okay, so now moving to the next question. I hope you have got this. So now next question is, a long signal x of n is frequency analyzed using rectangular window of length 40 milliseconds. If x of n is digitized using sampling frequency f of s is equal to 8 kHz, then determine the maximum frequency resolution of the analysis. So how we will solve this problem? Here the sampling frequency is given, that is 8 kHz, and the length of the window, rectangular window, is given 40 milliseconds. Okay, so given fs is 8 kHz and window length is 40 milliseconds. Okay, so already we know that the relation between the frequency resolution, window length, is frequency resolution is equal to f of s, sampling frequency, then number of points, DFT or FFT. Okay, and also we know that this relation T is equal to 1 by Fs. Okay, so sampling frequency is given 1 by 8. So what will be the sampling period? That is 1 by 8 kilohertz, so 0.125 millisecond, right? So that means for 0.125 millisecond is related to only one sample. Okay, so for 1 millisecond how many samples will be there? That is 1 divided by 0.125 samples, right? So similarly, for this 40 millisecond, how many samples we required? 40 millisecond, how many samples we will require? 0 divided by 125 multiplied by 40, right? So now if you calculate it, you will get 320 samples. Just divide it, you will get 320 samples. Okay, for 40 millisecond there is a 320 samples. Okay, so now put in this equation the frequency resolution is equal to Fs, that is Fs divided by n, right? So Fs is 8 kilohertz and n is 320 samples, right? So if you divide it, you will get 25 hertz. Okay, from here. So maximum frequency resolution is 25 hertz. So that is option D is the correct answer for this question. Okay, so have you got this question? Can we move to the next question? Okay, so moving to the next question. Okay, so this question, an image represented by a below matrix using a DCT function defined in equation 1, that is in equation 1, this one. So determine the value of Ci00 and Ci11. What will be the value of Ci00 and Ci11? The matrix is given as Ix comma y, this 3 cross 3 matrix, right? So that means n cross n matrix is given, that is 3 cross 3 matrix is there, n is equal to 3, that means the function is given ci comma j 1 by root 2n ki kj summation x and y varies 0 to n minus 1 I x comma y cos 2x plus 1 I pi divided by 2n cos 2y plus 1 j pi divided by 2n. Okay, and kn also given. Now we have to find out the values of the ki kj, then the values. So first we will find out the ci 0 0, that means I is equal to 0 and j is equal to 0. So ci 0 comma 0, right? Here n is equal to 3 because it is a 3 cross 3 matrix, already we have seen. So 1 by root 2n will be the 2 into 3 6. Now ki into kj, right? So now we here it is a k 0 0 because I and j both are 0. Okay, so k 0 and both are k 0s. So how we will find? So here it is given for n is equal to 0, the value is here, if we put n is equal to 0, so k0 will be 1 by root 2, and otherwise the kn is will be 1. All other values the kn will be 1. So k0 will be 1 by root 2 for n is equal to 0, right? So that means k0 is equal to 1 by root 2. So now put the values of k0 0. So I will first write it. Okay, so k0 into k0 because I and j both are 0. So I'm just removing it from here so that it is easy to solve, because here a lot of calculations are there. So now x varies from 0 to n minus 1, n is equal to 3, so that is 2. Similarly y varies from 0 to 2, so I x comma y into cos 2x plus 1 2x plus 1 I, but here I and j both are 0, so 0 into pi divided by 2 into 3. Similarly here cos 2y plus 1 0 into pi divided by 2 into 3. So it is 0, so cos 0 will be 1, right? Already we know that cos 0 is equal to 1, so it will be 1 1. So what we will get? 1 by root 6. Here k0 we have already got it, that is 1 by root 2. 1 by root 2. X varies from 0 to 2 and y varies from 0 to 2. I x comma y, because cos 0 into cos 0, cos 0 will be 1, this one will be 1. So already we have what we have got? I x comma y only. Okay, so 1 by 2 root 6. Okay, here we will get, and x varies from 0 to 2. First we will open this summation, that is y. So I x comma 0 plus I x comma 1. So y varies from 0 to 2, that means 0 1 and 2. So we will put I is equal to, first y is equal to 0, then 1, then 2, x comma 2. Okay, so this equation we have got. Now further we need to open this summation, then we will got the full equation. Okay, so I am removing all those things so that you can able to write. Okay, so ci 0 comma 0, that is ci 1 by 2 root 6. Now again we have to open this summation. So first we will put x is equal to 0, then 1, then 2. Okay, so I 0 comma 0 plus I 0 comma 1 plus I 0 comma 2. Now we will put in that place 1. So I 1 comma 0 plus I 1 comma 1 plus I 1 comma 2. Now we are putting x is equal to 2 in this whole equation. So I 2 comma 0 plus I 2 comma 1 plus I 2 comma 2. Okay, so now 1 by 2 root 6. So already we know that what will be the values. This is the matrix values only. I00, I01, I02, I10, 11, I12, I20, I21, I22. So this is the first row, first column. So I00, I01, I02, I10, 11, 12, then I20, 21 and 20. Okay, just putting all this matrix. This is a summation of all the matrix values. So 8 plus 2 plus 4 plus 6 plus 7 plus 8 plus 9 plus 2 plus 0. Okay, so 1 by 2 root 6. What will be the value of whole summation if you add this? So any of you are doing these questions? Are you trying to solve? Okay, so if you will add this, so you will get 46. Okay, so 46 divided by 2 root 6. So again if you just divide it, so you will get 23 divided by root 6. That means Ci00 value we have got 23 divided by root 6. Okay, so 23 root divided by 6. So either A option or option C will be the correct one. So we will see which option will be the no, not C. Only in option A we are getting 23 divided by root 6, but after solving Ci11 we will ensure that which option will be the correct one. So Ci00 value is 23 divided by root 6. Now we have to calculate the value of Ci11, this one. Okay, now I have to remove this place so that I can solve for Ci11. So I am removing it. I hope all of you have noted down. Okay, so I am removing it from here. Now we will calculate for Ci11. So that means I and J will be 1. So 1 by root 2 n is 3, so just 2 into 3, right? Ki value is 1, so k1 and kj also 1. Okay, now here x vary 0 to 2 and y also will vary 0 to 2. I x comma y cos 2x plus 1. I is 1, so I only pi will left here. 2 into n, that means 6. Similarly here for 2y plus 1 into pi divided by 6. Okay, So this is the equation for this one. And here if n is equal to 1, that means the kn value will be k of 1 will be equal to 1. Okay, so these value will be the 1 only. So 1 by root 6 into 1. So first again we will open this for this summation for y, then we will open for x. Okay, so here x is equal to 0 to 2. Here we are opening for y. So I x, first we are putting y is equal to 0, then 1, then 2. So I x comma 0 cos, here we are putting x is equal to 0, so 1 only left, so pi by 6, right? Cos pi by 6. Similarly here we are not putting for in here x will be there, so no 2x plus 1 will be there. Okay, 2x plus 1, so sorry, so here will be 2x plus 1 pi divided by 6. Here cos, here y is equal to 0, so cos pi by 6. Okay, now plus I x comma 1, now y is equal to 1. Okay, so x value will be same, 2x plus 1 pi by 6 into cos, here y is equal to 1, so 2 into 1 2, 2 plus 1 3 by 6, so 3 by 6, so pi by 2 we will get here, right? 3 by 6, so 1 by 2, right? So cos pi by 2 plus I x comma 2, now y is equal to 2 we are putting, so it will be the 2x plus 1 pi divided by 6 into cos, here y is equal to 2, so 4, so 5 pi by 6, right? So 5, sorry my pen is stop working, so it will be the very 5 pi by 6. Okay, so this equation we have got. Okay, now we need to put the values of x also. X is equal to 0, then 1, then 2. Okay, so I am removing it from here so that we can just complete it. Okay, so just putting all those values here. Okay, I am removing this line also, so that because otherwise we will not able to write it here. So I hope all of you have noted down. Okay, so just putting the values of all those, so we will get 1 by root 6. If we open that, x is equal to 0, so just putting at place of x is equal to 0, then 1, then 2. Okay, so I 0 comma 0 into cos, so my pen is stopped working, so it is very difficult to write here. otherwise we don't have much time. Okay. So cos, if we put x is equal to 0, so here we will get first x is equal to 0, so here we will get pi by 6. Okay, cos pi by 6. So already I have noted down. So first value is also again here cos pi by 6. Okay, so I00 cos pi by 6 into cos pi by 6. Okay, now we will be putting I0 comma 1 cos, we will get here cos pi by 6 into cos, next value is 0 comma 1, pi by 2 will be there, so you can separately calculate it. Now next value is I0 comma 2 cos pi by 6 into cos 5 pi by 6. Okay, this one is 6. Now put, so can we solve till this equation, because there is a very long equation will be there. So we have put in currently I or x is equal to 0. Now we have put for x is equal to 1, then x is equal to 2. Okay, so just a minute, I can take one more slide so that it is easy. So just a minute. Okay, so I'm writing now, putting x is equal to 0, then x is equal to 1, then x is equal to 2, whole equation. Okay, here ci 1 1, further you can see, okay, 1 by root 6, the value will be I 0 comma 0 cos pi by 2 into cos pi by 6. Can we move currently for next question, then it will start working, then we will again solve this question. Actually it is very difficult to write currently if it will not work, and you will also not able to understand. Okay, so I am writing again. Okay, it started. Okay, so I am writing the whole equation here. Okay, so I 0 comma 0 cos pi by 6 into cos pi by 6 plus cos 0 comma 1, sorry, I 0 comma 1 cos pi by 6 into cos pi by 2 plus I 0 comma 2 cos pi by 6 into cos 5 pi by 6. Here we have put in our x is equal to 0 only. Okay, now x is equal to 1. So I 1 comma 0 cos pi by 2 into cos pi by 6. You can see it, you can check it. Okay, so just putting in that equation and expand it. Okay, plus I 1 comma 1 cos pi by 2 into cos pi by 2 plus I 1 comma 2 cos pi by 2 into cos 5 pi by 6. Okay, now 1 has been completed. Now by putting x is equal to 2, so I 2 comma 0 cos 5 pi by 6 into cos pi by 6 plus cos 2 comma 1 cos 5 pi by 6, sorry, cos 5 pi by 6 into cos pi by 2 plus now for I22 cos 5 pi by 6 into cos 5 pi by 6. This is a whole equation you will get if you expand both the summation, this much of large equation. Okay, now if you see that what is a cos pi by 2 value, cos 90 will be 0. So wherever the cos pi by 2 will be there, that function will be 0. That means this will be 0 and this will be 0, I11 will be 0, right? I21 will be 0. So whole these functions will be 0. Okay, now all other places you can put the values. So 1 by 6 I00. What is the value of I00? So from here you can see that that is 8. I01 is 2. I02 is 4. Just putting all those values in that equation. Okay. So now I am directly putting, you can see that. So I00 is 8 and cos pi by 6 value, if you calculate it, you will get that is equal to root 3 by 2, and for cos 5 pi by 6, if you calculate it, you will get minus root 3 by 2. Okay, you can personally calculate it and see that. So 8 cos pi by 6 is root 3 by 2 into root 3 by 2 plus this value is 0. Now cos I02. So what will be the value of I02? I02 is 4. Okay. So 4 into cos pi by 6, that is root 3 by 2 into cos pi by 6. So just I am putting it because it is written in form of cos pi by 6 in options. Okay. Now plus. So I02 we have I10 value is 0. I11 is also 0. Now I12. So what will be the value of I12? No, I12 is also 0 because here cos pi by 0. So it will be also 0. Now what we have cos, sorry, I20 will be there. Yeah. So I20 value is 9. Right? So I20 is 9. Cos pi by 6 is root 3 by 2 into cos 5 pi by 6. Okay, here cos 2 1, this function is also 0. So what left? I22. So I22, if you see that here the value itself 0, I22 is 0. Okay, so that means this function will be also 0. Okay, now just calculate these values. So 2 4 ja 8, 2 2 ja. Okay, so you will get 1 by root 6, 2 root 3, 2 3 3 6, that means 6 plus, here you will get 2 2 ja 4, so 2 root 3 cos 5 pi by 6 plus 9 root 3 divided by 2 cos 5 pi by 6. Okay, now if you further calculate it, so I am removing it from this side from here so that I can write. Okay, so see 1 1, finally you will get 1 by root 6, so 6 plus 13 root 3 divided by 2. Okay, 13 root 3 divided by 2 into cos 5 pi by 6. Okay, so this will be the final answer. 1 by root 6 in bracket 6 plus root 13 root 3 divided by 2 cos pi by 6. Okay, so this option is not matching. Here is only 8 plus 13 cos pi by 6. So it can be a correct answer, but the second CI11 value is not correct. So it will be the 6 plus 13 root 3 divided by 2 will be there into cos pi by 6. Okay, so here no option is the correct, but more potential correct option is option A. Okay, okay, so I hope you have understand this question. So moving to the next question. So now next question is, if a DFT is applied to the input as in question number 12, this question DFT is applied, so determine the number of real multiplication required for that. How many real multiplication of required? So number of real multiplication in DFT is equal to number of real multiplication is equal to 4 n square. Already we know that. Okay, in DFT, so n already we know that n is equal to 3, n is equal to 3, it is given. So how many real multiplication will be there? 4 into 3 square, we will get 36. Okay, so they have asked, if the DFT is applied in this equation, determine the number of real multiplication required for that. Okay, so already we know that for both we have calculated for the two values, that is C00 and C11, C11, right? So for one calculation C00 we require 36, and for other one is also required 36. So total number of real multiplication is required for that question is 72 for both. Okay, so that's why option C is the correct answer for this question. Okay, so I hope you are getting. So moving to the next question. Okay, so next question is, which of the following transform is most widely used for form for the lossy image compression? So first one, two-dimensional discrete Fourier transform, one-dimensional discrete cosine transform, two-dimensional discrete cosine transform, or two-dimensional short time Fourier transform. So already we know that for image compression, for glossy image compression, we require the two-dimensional discrete cosine transform. So that's why option 3 is the correct answer. A detailed answer is given the next slide, that is this. The 2D discrete cosine transform is most widely used transform in glossy image compression method, in such as JPEG. Okay, so it separates an image into a different frequency components by allowing high frequency details which are less perceptible to human eyes to be compressed for more aggressively while retaining the most important visual information. So 2D DCT is preferred over the 2D DFT in order to avoid the complexity or complex number of multiplications and achieve a better energy compaction. So already we have seen that 2D DCT provides a better energy compaction and less complexity. So that's why 2D DCT is widely used for image compression techniques. Okay. So the two-dimensional discrete Fourier transform used in signal processing, but not ideal for image compression because its nature, complexity nature, and lower energy compaction. And 1D DCT is used only for signal, for like audio, but not suitable for 2D signals. And two-dimensional STFT is used for time frequency analysis, not for image compression. Okay, it is used for speech and audio processing. Okay, so I hope you have got this question. So moving to the next question. Now next question is, if a signal consists of two frequencies, that is 1000 Hz and 120 Hz, what minimum window length is required for STFT to resolve them separately? So what window length will be required? Okay, so here given the two frequency components, that is given two frequency components, that is f1 is equal to 1000 Hz and f2 is equal to 1020 Hz. Okay, so already we know that the frequency resolution del f is equal to f2 minus f1, so that is 1020 Hz minus 1000 Hz. So from here you will get 20 Hz. Del f is equal to 20 Hz, right? So now the window length will be, the sampling frequency is not given, so window length is equal to 1 by del f. Okay, so that is 1 by 20 Hz. From here you will get 0.05 seconds. So if you further calculate it, so you will get 50 milliseconds. Okay, so option B is the correct answer for this question. Okay, so I hope you are getting. So moving to the next question. So now next question is, frequency domain analysis of a signal x of n is equal to 6 cos 0.2 pi n plus 15 cos 0.4 pi n is done using rectangular window of length L. The frequency components of the signal are resolvable for which of the following window length L, where sampling frequency is 16 kHz. Okay, so sampling frequency is given. So we have seen in that theoretical section one formula, that is W2 minus Wn is equal to 2 pi by L. So here this signal is given. What will be the Wn? Wn is 0.2 pi and W2 is equal to 0.4 pi. Okay, so this is the relation between this frequency component and window length. So if you further putting in this equation, you will get directly 0.4 pi minus 0.2 pi is equal to 2 pi by L. So from here you will get 0.2 pi is equal to 2 pi by L. Now further L is equal to 2 pi divided by 0.2 pi, right? So if you do that, pi and pi, so here you will get 0.1. So L is equal to, you will get 10. So the window length will be the 10. Okay, so the length of the window is 10. That means option A is the correct answer for this question. Okay. Okay, so I hope you are getting. So moving to the next question. Now next question is, a signal is analyzed using STFT with window size of 512 samples and an overlap of 50%. 50% is given. Okay, if the signal has a sampling frequency of 16 kilohertz, then what is the time step between the consecutive STFT frames? Okay, what will be the time step between the consecutive STFT frame? Okay, so here window size is given. So given window size is equal to 512 samples and overlap is 50%. Overlap is equal to 50%. That means 0.5. Okay. Now the step between windows will be step, time step between windows equal to 512 into overlap, that is 0.5, right? You will get 256 samples. So this is a time step between the windows. Okay, now time step between the frames. Time step between frames will be, that is step between the windows, that is also called hope size. Okay, this is also called hope size. Hope size. There is a windows divided by sampling frequency. Sampling frequency. So already we have calculated, that is a time step between windows, that is 256 samples divided by sampling frequency, that is 16 kilohertz. 16 into 10 to the power. So if you further you just divide, so you will get 0.016 second. So which is equal to 16 millisecond. Okay. So option A is the correct answer for this question. Okay. So I hope, are you getting these questions? So moving to the next question. Next question is, which of the following window function provides better frequency resolution? Option A is rectangular window, option B is Hanning window, option C is Blackman window, and option D is Hamming window. So we will see the detailed explanation in the next slide. which of the following window function provides better frequency resolution? That is a rectangular window. So option A is the correct answer, but we will see the detailed solution here. So the frequency resolution of a window function depends on the main lobe width and side lobe level, okay, in the frequency domain. So in the rectangular window provides the narrowest main lobe, best frequency resolution, but has a high side lobe, poor spectral leakage. But in the Hamming and Blackman window have a wider main lobes, if you have seen, poor frequency resolution but lower side lobe, better noise suppression. Okay, so it depends on our application which window we will use, whether we need a best frequency resolution or better noise suppression. So it depends on our application we will use. So but for the question they have asked which provides a better frequency resolution, so which one is a rectangular window provides a better frequency resolution here. Narrowest main lobe, that means best frequency resolution it will provide. So for the comparison we have done in all four windows. So rectangular window provides best frequency resolution but high spectral leakage. Hamming window wider main lobe has lower side lobes but moderate resolution. Hamming window is similar to Hamming with slightly better side lobe suppression. And Blackman window widest main lobe but best side lobe suppression. Worst frequency resolution Blackman window. So best frequency resolution provided by rectangular window. That's why option A is the correct answer for this question. Okay. Now moving to the next question. So next question is STFT analysis of speech segment is required for noise reduction. If the STFT analysis is done based on the Hamming window of length 20 millisecond, here they have given Hamming window, okay, of length 20 millisecond, determine the maximum frequency, maximum possible temporal decimation factor. So that signal is completely invertible when the sampling frequency fs is 16 kilohertz. Okay. So already we know that for Hamming window bandwidth, what is the formula for Hamming window bandwidth? B is equal to 8 pi by NW, okay, where NW is the samples in total number of samples in window length samples. So I am just writing window length sample, that is represented by here, and W is equal to total window length. What is a window length? Multiplied by sampling frequency, that is fs. So window length is given 20 millisecond, 20 10 to the power minus 3 into the sampling frequency is given 16 kilohertz. Okay, so if you just do that, you will get 320 samples. Okay, so already we know that Hamming window bandwidth is this. Now in general the window length so they have what will be the maximum temporal decimation factor. So decimation factor, we can here write decimation, here window decimation factor LW must be less than equal to 2 pi by P will be there. So B is the bandwidth. So if we put L, we will get 2 pi by 8 pi divided by NW. So from here you will get NW divided by 4. Okay, so NW we have calculated, that is 320 samples. So 320 divided by 4. So here it will be the total 80 samples will be there. So which option? Option C is the correct answer for this question. Okay. So okay, I hope you have understand this question. So moving to the next question. So next question is, a signal x of nk is the STFT of a signal xn of n, and analysis is decimated in time by a factor L, where Wn is the non-zero over its length nw. X of n is invertible for which of the following conditions? So options are given here. Options not the for which of the following condition it will be the invertible. So the temporal decimation factor L must be less than equal to n of w, and the frequency sampling interval must be 2 pi by n less than equal to 2 pi by n by w nw. The temporal decimation factor L must be greater than n of w, and the frequency sampling interval 2 pi by n must be greater than equal to 2 pi by n w. So which of the following conditions must be correct? Option A is given first and fourth is the correct condition. Option B is first and second is the correct condition. Option C is third and fourth is the correct condition, or option D is the second and fourth is the correct conditions. So already we know that the temporal decimation factor L must be less than equal to L plus, we have solved in the previous question slide. Okay, n of w must be less than 2 pi by b. So 2 pi b here not given, so n must be less than equal to non-zero its length, okay, window length, and the frequency sampling interval must be 2 pi by n less than equal to the 2 pi by n w to retrieve our original signal. The detailed solution is here. Okay, so we are given that xnk is the short time Fourier transform of xnn. STFT analysis is decimated in time by a factor L, and analysis window w of n having length n w. Okay, so to ensure that original signal xnn is perfectly invertible, so STFT should be satisfied the two important conditions. First one is a temporal decimation condition. Now next one is a frequency sampling condition. So the hope size, that means decimation factor, must be less than or equal to the window length to allow full reconstruction via overlap add method. So this is the L must be less than equal to nw. Okay, now next condition is frequency sampling condition. So the frequency sampling interval should be sufficient fine to capture all the spectral details. So the discrete frequency resolution of the STFT must be 2 pi by n must be less than 2 pi by nw. So to this ensure that frequency domain representation does not have excessive aliasing. So 2 pi by n must be less than equal to 2 pi by nw. So from here we can say that option, these two conditions must be satisfied to get the invertible signal. Okay, so option B is the correct answer for this question. Okay, so I hope you have understand these questions. Now the questions have been completed. So now if you have any doubt you can ask, otherwise we can close the session. Okay, so any one of you have any doubt, anything? Okay, so we can close the session. Okay, so thank you for joining this session. Now we are closing the session. Okay, Anis, so you can leave the session now. We are closing. Okay, thank you everyone, thank you for joining session.